Hey everyone, it is Miss Lloyd here. We are looking at some complex numbers, and complex just means that we're looking at numbers that aren't real, aka they are imaginary. I always think of SpongeBob and he goes like imagination with the rainbows. Exactly what I think of whenever I'm doing these. So imaginary unit, something is imaginary whenever we're trying to take the square root of a negative number. So if you think about your square roots, they're undoing squares. So if we have something like 5 squared, that's going to give us 25. And if we have something like negative 5 squared, that's negative 5 times negative 5, which is a positive 25. So no matter if we're squaring a positive or a negative, we're always going to end up with a positive number. So then we shouldn't be taking the square roots of negative numbers. But sometimes we end up with negatives underneath the square root. And so in this case, we have the imaginary unit I. So anytime we have the square root of a negative 1, we replace it with I instead. And then we have our complex numbers, which are a combination of real and imaginary. So we have typically a real plus or minus some number that has an imaginary unit with it. My first example here, we're just looking at a square root, and we definitely have a negative underneath. So one of the first things that I like to do is to separate that out. I know that in order for us to have a negative 32, it has to be multiplying with a negative 1. And then I don't know the square root of 32, but I know that there's probably something inside of 32 that I know the square root of. So first thing that comes to my mind is 16. If I divide 32 by 16, I end up with a 2. So instead of 32, I can say that I'm multiplying 16 times 2. And I can separate all of these. I can take the square root of negative 1, which will give me I. I can take the square root of 16, which will give me 4. And I cannot take the square root of 2, so that's going to stay underneath. And then we're done. My next example, I'm going to simplify as best I can, and then I have a subtraction sign. So hopefully if I have the same number underneath those radicals, then I can combine the radicals. So I'm going to simplify the negative square root 6 and the negative 24. So now that I've got this simplified, I see that we have a square root 6 and a square root 6. We can treat these as like terms because we have the same number underneath our radical. So I'm going to add my 5i and my minus 2i. So technically I'm subtracting, and I would end up with 3i square root 6. So the I and the square root 6 kind of work the same way as if we had an x or an x squared. If we have terms where the numbers both have the I and the same number underneath that radical, we can combine them. And then this next one, we have multiplication. Before we multiply something that has a negative underneath the square root, we want to take that out. So when we do this, if I were to multiply the negatives while they were inside, then the negatives would go away and it would be like they never existed. But they did exist, and so I need to keep them separate. The next thing I want to do is multiply. So my I times my I is going to give me I squared, same as x times x would give you x squared. And my square root 3 times square root 27 is going to give me the square root of 81. So our I squared, whenever we do this, an I squared, we know that I is the square root of negative 1, and I'm squaring this. So when I square that square root, that will cancel, and I'm just left with a negative 1. So I squared is equal to negative 1. And I know the square root of 81 is 9. So multiplying those two together, I would end up with negative 9 as my final solution. All right, now we have some of complex numbers. So this is when we're combining the real numbers with the real numbers and the imaginary with the imaginary. So it's just like terms. You can only combine an x with an x and a y with a y. So a quick example, if I can, would be 4 plus 7i, and we're adding this to 3 plus 4i. So when I'm doing this, I want to combine my real terms together. So I have 4 plus 3. 4 plus 3 will give me 7. And then I have my 7 and my 4i. So 7i plus 4i is going to give me 11i. So plus 11i. And 7 and 11, 7-Eleven, that's a gas station in the US. 7 and 11 are not like terms because the 11 is imaginary, the 7 is real, so they're just going to hang out next to each other like good real and imaginary friends do. When we are multiplying, I kind of already went through this. Anytime we have two i's multiplying together, it gives us I squared, and I squared is equal to -1. And we're going to use a distribution method the way we would do if we had variables. So I have my 4 times my 3 will give me 12. And then I end up with minus 28i squared. So when I'm simplifying, I know I can combine what I just have an I of. And I want to change my I squared to a -1. So the negative 28 times a -1 would give me a positive 28. So then when I'm adding this stuff together, 12 plus my 28 is going to give me 40. And my 16i minus my 21i is going to give me -5i. And again, we only have one real and one imaginary, so this is as far as we can go. This next one, I'm going to say for my kiddos. I will go over this one here with us though. Whenever I have this exponent, order of operations says we need to worry about exponents before multiplication. I also think it's just a little bit simpler. Technically, exponents are multiplication, and so we could kind of do whichever order we wanted to in this case, but I think it's a little bit less complicated if we do the distribution of the 2i minus 1 squared before we worry about that 3i on the outside. So I know with that squared, I'm writing it twice. And then I'm going to do my distribution. Next, I want to simplify. Again, changing my I squared to a -1. And once I have everything inside simplified to one real and one imaginary, then I can distribute in my 3i. And then I'm finished. So next bit, just like with square roots, I mean, technically an I is a square root of -1. So because I is technically a square root, we do not want it in the denominator and need more than we want the radicals in the denominator. So we use these conjugates in order to eliminate our imaginaries so that we no longer have them in the denominator. So here I'm going to go just a quick proof on how that eliminates. And then we're finished. So an example of how we would do that. So here I have an imaginary in the denominator, which means I technically have a square root. We don't like that, so we're going to rationalize. I'm going to use a conjugate, meaning instead of 2 minus 4i, I'm using 2 plus 4i. What we do in the denominator, we also have to do to the numerator. So first I'm going to distribute in the top stuff, so my numerator. Then I'm going to distribute in the denominator. I'm going to change any of my I squareds into -1s and cancel out some imaginaries, and I'll combine my like terms. Now that I have everything simplified top and bottom, I can look and see if we have anything in common. And 20, 10, and 20, I can take a 10 out of everything, which will reduce it all to 2 plus 1i, or you can just put I, all over 2. And we're finished. Now, when it comes to the standard form of complex conjugates, it just means that we're going to fully separate the real and the imaginary. So if they wanted me to put our previous answer into standard form, I would have it as 2 over 2 plus I over 2, which I could then simplify a bit more to 1 plus half I. And that would be our standard form. So here we also have standard form, not just when we have fractions like that, but if we have any kind of imaginary. So for this, they want us to perform the operation, meaning they want us to do the square, and then write it in standard form, so making sure that we have a separate real and imaginary term. The first thing I'm going to do before I work with this is fix this negative underneath and change it to an I. And I also know the square root of 4 is 2, so this will end up being a 2i. A little bit easier, at least for me, to work with than with a square root negative 4. And because I have a square, that means I'm writing this twice. And I can do my distribution. Simplifying my like terms and changing my I squared to negative 1. I end up with 21 minus 20i. And I don't have any fractions here, so this is as standard as it's going to get. I hope this was helpful. If you found this helpful, please like and subscribe. If you know of someone who could use any of these examples, please feel free to share it. Sharing is caring. Spread the love.